So I'm going to review the concepts from modules 5, 6, 7, and 8 that you may see on the final. So starting with module 5, where we were solving systems of equations and inequalities. So the first thing we talked about was solving by graphing, substitution, or elimination. And I'm not going to go over solving by graphing because you just would plug the system of equations into Desmos and look where they intersect. What I am going to review is substitution and elimination. So the first one I'm going to do is substitution. Okay. Substitution is when you get one of the variables isolated, so you can plug it in for that variable in the other equation. And in our first example, y equals x plus 2 and y equals negative 3x minus 2, the y's are both isolated, so we can actually go ahead and set them equal to each other to solve for x. So I'm going to add 3x. Then we're going to subtract 2. And then divide by 4. And we get x equals negative 1. Okay. Now that we know x, we're going to plug it into one of the original equations to solve for y. It doesn't matter which equation you plug it into, and in this case, the x plus 2 is a little bit easier to plug it in, and then negative 1 plus 2 is 1. So our solution is that x negative 1 and y is 1. And you can use Desmos to verify this is solution. And then if you're going to write the solution as a point, remember your parentheses, and then it's always x comma y. The second example I'm going to do I'm going to use elimination. So in elimination, you pick the variable that you want to eliminate. So you pick a variable that you can multiply one or both equations by a value or values that would get the same variable in both equations to have the same coefficient but opposite signs. So we have the system negative 5x plus 2y equals 1 and x minus 3 equals 5. So when I'm trying to figure out which variable to eliminate, I try to go for the variable that already has opposite signs. I try to avoid multiplying by negative if possible. And x and y are already opposite signs here, so that's not a factor. The second thing I look for is there a way I can multiply only one equation to eliminate a variable. So it's not that difficult to make the y's the same. I could make them both 6, but that would involve multiplying both equations. But if I multiply the second equation by 5, I can get the x's the same and I only have to multiply one equation. No matter which variable you choose to eliminate first, you're going to get the same solutions. So I'm going to leave my first equation alone. And then I'm going to go through and multiply everything in my second equation by 5. So we get 5x minus 15y equals 25. And it's important to remember that with elimination, you are adding the two equations together. So the x's will cancel. 2y plus negative 15y is negative 13y. 1 plus 25 is 26. Divide by negative 13, and we get y equals 2. So again, doesn't matter which equation I plug that into to solve for x. I'm going to go ahead and choose the second one. So x minus 3 times negative 2 equals 5. So we get x plus 6 equals 5. Subtract 6, x equals negative 1. Which if I'm going to write as a point is negative 1 comma negative 2. So that is substitution and elimination. Next, we're going to look at a word problem. So this problem says the Lakers scored a total of 80 points in a basketball game against the Bulls. The Lakers made a total of 37 2-point and 3-point baskets. How many 2-point shots do the Lakers make? How many 3-point shots do the Lakers make? Write a system of equations to represent this problem, then solve. So anytime you have a word problem, the first thing you need to determine is what your variables are going to represent. And in this case, it's number of 2-point shots and number of 3-point shots. So when I'm coming up with my system, I know they made a total of 37 baskets. So I know my number of shots made, the x plus y, has to equal 37. For my second equation, so I got that from the total of 37 2-point and 3-point baskets. For my second equation, I'm going to use the fact that the Lakers scored a total of 80 points. Now, we are going to assume here that they only scored 2-point and 3-point baskets. We're not going to take into fact any 1-point baskets that were made. So that tells me that 2x plus 3y has to equal 80. Because obviously, 2-point shots are worth 2 points, 3-point shots are worth 3 points, and that's how I get my 80 points. Now I can decide to solve using substitution or elimination here, and it doesn't matter which. I personally am a fan of elimination, so that's the route I'm going to go, but substitution is not that difficult here. So I'm going to go ahead and eliminate x by multiplying the first equation by -2. So we'll get -2x minus 2y equals -74. And then our second equation, 2x plus 3y equals 80. Add our equations together, and we get y equals 6. So that tells me they made 6 3-point shots. All right, and then to solve for x, I'm just going to use the fact that x plus y has to equal 37. So x plus 6 is 37. Subtract 6, and x equals 29. Now, the only reason I would have to write a sentence here is if I didn't define my variables. So because I already defined what x and y are, I can just leave it as y equals 6, x equals 29. I can also write out that they made 29 2-point shots and 6 3-point shots, or baskets. Either one works. What I'm not going to do is write it as a point, because you get to pick what your variables represent. So when we're dealing with word problems, the one thing we don't do is ever write our solution as a point. Next, we were looking at inequalities. So when we're given an inequality, we have kind of two choices when it comes to selecting the points that satisfy the inequality. We can graph our inequality in Desmos and then plot all of our points and figure out which of them fall within the shaded region. We can also plug in our values for x and y and see if they make the inequality true, which that's the method I'm going to do, because again, if you're going to use Desmos, you can just graph it. So the first point I'm going to check is 0, 0. So I want to make sure that 2 times 0 is less than 0 minus 3. So 2 times 0 is 0. 0 minus 3 is -3. And 0 is not less than -3. So I know it is not a solution. So that tells me if I were to graph this in Desmos, 0, 0 would not be in the shaded region. Next, I'm going to check -3, 5. So 2 times -3 is going to be less than 5 minus 3. So I get -6 is less than 2, which is true, which means it's a solution. Next, we have -1, -4. So I get -2 is less than -7, which is not true. And then our last point, 130. So 2 times 1 is less than 30 minus 3. So I get 2 is less than 27, which is true. So no matter which method you choose, both should give you the fact that -3, 5, and 130 are the only points in the shaded region. Important thing to point out here is that because this is a strictly less than inequality, points on the line are not solutions, because that's the equal to case and there's no equal to here. So points on the line are not a solution. The last thing was writing an inequality that represents the graph, or given an inequality, figuring out which graph matches. So the first thing I'm going to do here is figure out my slope and y-intercept. Okay, so I'm going to pick my x-intercept and my y-intercept to help me find my slope. And I only use these because they're both whole numbers. I typically use whole number points when I'm finding slope and y-intercept. So I have to go down 4 and right 2 for my slope, so -4/2, which gives me a slope of -2. And my y-intercept is, of course, 4. So I'm going to start with an equation. So we'll have y, and then it would be equals, but I'm not going to write it, -2x plus 4. Now I have to determine my inequality. So remember, if you have a dashed line, that means you're dealing with less than or greater than. If you have a solid line, that's a less than or equal to or greater than or equal to situation. So because this line is dashed, I know that it's going to be either less than or greater than. And then I did shade below the line, which means it is going to be less than. And like always, you can use Desmos to verify. If I graphed this inequality in Desmos, it would match the graph that I'm given. So next, we worked on Module 6, which was all about quadratics. So the first one we want to look at is given the equation y equals 2x squared plus x minus 10. We want to find the vertex, the y-intercept, and any x-intercepts. So we did all of this using Desmos. So I'm going to type my equation in Desmos. So the first thing I'm going to look for is the vertex. So a vertex is the highest or lowest point on a graph depending on which direction the parabola opens. So because this parabola opens up, I'm looking for the minimum point, which in this case happens to be at -0.25, comma, -10.125. Okay. My y-intercept is going to be, again, looking at the graph, 0, -10. I could also use the equation here because if you're given an equation in standard form, which is what this equation is in, the y-intercept is always the constant at the end of the equation, which is -10. And the last thing are the x-intercepts, which using at the graph are at -2.50 and 20. Next, we have vertex and intercept form. So vertex form is y equals a parentheses x minus h squared plus k, where hk is the vertex. Okay. So again, using Desmos, I'm going to go ahead and type in the equation. Okay. All right, so again, this is going to open up, so I'm looking for the lowest point. So my vertex is going to be at 5, -22. So when it comes to vertex form, we're going to do y equals, a is the number that is in front of x squared. And in this case, the number in front of x squared is 1 here. So a would also be 1, which we typically write. So then I'm going to do x minus my x value for my vertex, which is 5, squared, and then plus k, but because k is -22, I'm going to write -22. So remember, when we're writing vertex form, it's the opposite of what's with x in parentheses, and then outside the parentheses, you keep the value of y. And again, I can't stress enough how important verifying your equation with Desmos is. And then we had intercept form. So that's y equals a times x minus p times x minus q. In this case, P and Q are the x-intercepts. So there's a couple different ways you can go about this. One method is to, intercept form is also known as factored form. So what you could do is factor the quadratic you're given, and that would put it directly in intercept form. Your other option is to go ahead and graph the equation in Desmos. Both will result in the same equation, so it doesn't matter which one you use. So if I graph the equation in Desmos, my x-intercepts are at -6 and -2. Okay. When we are putting an equation in intercept form, okay, it starts off with y equals. A is the same thing as it was for vertex form. It's the number in front of x squared, which is again 1. So we're going to write anything. When I put the x-intercepts in the parentheses, they have to have their opposite sign. So instead of saying x minus 6, I'm going to say x plus 6. And instead of x minus 2, it's going to be x plus 2. Because with x-intercepts, they're the values when x is 0. So how I get them is if it were in factored form, I would take the factor x plus 6 and x plus 2, set it equal to 0, and solve for x. And that's how I get -6 and -2. And in this form, if I check, if I'm going to use factoring, I have to find numbers that multiply to 12 and add to 8. And if I use +6 and +2, it multiplies to +12 and adds to +8. If I used -6 and -2, while they would multiply to +12, they would add to -8 instead of +8. Again, make sure you're using Desmos to check your answer. All right. Next, we talked about transformations. So we have the graph y equals -x minus 1 squared plus 3. And we want to know the transformations that have occurred from the parent graph y equals x squared. So you can use Desmos. You don't have to, but you can. So if you have a negative in front, that indicates a reflection. So a negative in front is a reflection. Then we look at any value being added or subtracted with x inside a set of parentheses. And in this case, so what that means is it's a vertical translation. And more specifically, in this case, it's going to be right 1. Most people think that if I have a -1 inside that parentheses, I've moved left, because most people think, because when graphing, negative is in the direction of left. But just like with when we were thinking back to vertex form, if my vertex was at had a positive x value, I put it in the parentheses with a minus sign. Okay. And then lastly, we have the +3. So that is a horizontal translation, which means up or down, and in this case it would be up 3. So you can still use Desmos to again verify this. So the original graph would be the y equals x squared. The new graph would be the y equals -x minus 1 squared plus 3. And you can verify it's been reflected, it moved right 1, and then it moved up 3. Lastly, we have the quadratic formula. So just to rewrite that, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So what it allows us to do are to solve for the solutions to a quadratic equation. And the solutions are those x-intercepts. In order to use the quadratic formula, your equation has to be equal to 0. So we have the equation -10 equals x squared minus 7x. So what I'm actually going to do first is add 10 to both sides, so it's equal to 0. So we have x squared minus 7x plus 10 equals 0. And what I like to do is identify a, b, and c before I plug it into the equation. Now this is not mandatory or required for full credit, but it's just something I like to do. So a is 1, b is negative 7, and c is going to be positive 10. So when I plug it into the formula, we're going to get x equals negative b. Now because b is already negative 7, it's going to become positive 7, plus or minus the square root of negative 7 squared minus 4 times 1 times 10 all over 2a. Whoops, so 2 times 1. The rest of the formula is just simplifying that initial step. So 7 plus or minus, and when I square negative 7, I get positive 49. And then negative 4 times 1 times 10 is going to give us minus 40 all over 2. Then 49 minus 40 is 9, so 7 plus or minus 9 all over 2. And then I can take the square root of 9, so we got 7 plus or minus 3 all over 2. Now, because I can take the square root of 9, I'm not going to leave it as 7 plus or minus 3 all over 2. What I'm going to go ahead and do is split that up into the addition and subtraction and find my two solutions. So 7 plus 3 all over 2 and 7 minus 3 all over 2. So 7 plus 3 is 10, and 10 divided by 2 is 5. And then 7 minus 3 is 4 over 2, which is 2. Okay. Now, if I hadn't gotten a perfect square underneath the square root, like if I had gotten 10 instead, I would have left it as 7 plus or minus the square root of 10 all over 2. If the square root isn't a whole number, if it's not a perfect square, just leave it underneath the square root. I don't want decimal answers here. Next, in Module 7, we were looking at exponential relations. So we first talked about whether or not an equation represented exponential growth, decay, or neither. So the important thing to remember about exponential equations is that the variable appears as the exponent in the equation. So we have, for our first one, y equals 4 times 3 to the x. So our variable x appears in the exponent, so it is an exponential equation. So when I'm trying to determine growth or decay, I look at the base number. So if the base number is greater than 1, it's growth. And if it's a fraction between 0 and 1, it's decay. So we always care about that base number, the number that has the exponent. So in our first equation, our base number is 3, and 3 is greater than 1, so this is growth. Our second equation, y equals negative 3 times 3/4 to the x. Our base number is 3/4, which is between 0 and 1, which means it represents decay. Next, we talked about converting between exponential and logarithmic form. So just to kind of refresh, exponential form is b to the x equals y, and logarithmic form, or log form, is log base b, oh, it wasn't y, it was a, of a equals x. So whatever the base of your exponential equation is becomes the base of your logarithm. So for our equation, 4 to the x plus 3 equals 10. When I'm converting it to a logarithm, my base of 4 stays the base of the logarithmic equation, which is 4. Then inside the parentheses, I put my number 10, and then we become equal to our exponent, which is x plus 3. The whole entire point of converting an exponential equation to logarithmic form is to solve the equation for our variable x. So now that it's in this logarithmic form, I could solve for x if I wanted to, which I'm not going to do right now, but I am going to do in a second on some examples. So next what I'm going to do is solve our exponential equation. So I am going to convert it to logarithmic form. I'm actually going to show you two methods because I could solve this equation in one of two ways. So I'm going to show you by converting to log form first. Okay. So when I convert it to log form, my base, which is 3, becomes the base of the logarithm of the number 81 equals my exponent 9x. Now, in order to evaluate log base 3 of 81, I'm going to use the change of base formula. All right. Some of your calculators may allow you to evaluate logarithms with different bases, which if they can, great, use it. But if they can't, you're going to want to use the change of base formula, which says to do the log of A divided by the log of B. And it is important here to remember those parentheses around side the numbers in the numerator and denominator. Okay, so it will become log 81 divided by log of 3. So we get 4 equals 9x, and then to finish solving for x, we'll divide both sides by 9, and we get x is 4/9. And I am going to leave it as a fraction here. This was not the only way to solve this equation. I could have also used something called common base. So common base can't be used all of the time. It can only be used if the number you're equal to, or the number without the exponent, can be rewritten as the other base raised to an exponent. Like in this case, 81 can be rewritten as 3 to the 4th. So it would be 3 to the 9x equals 3 to the 4th. And now that they have the same base, we kind of ignore them and we set the exponents equal. So the 9x equals 4, still divide by 9, we still get x equals 4/9. But common base can't always be used. Like on that previous example I just did with the 4 to the x plus 3 equals 10, I can't use common base to solve that. I would have had to convert to log form. So log form can always be used to solve an exponential equation. Common base, it really depends. So I recommend always using logarithmic form because it will always give you the correct answer. The last thing we discussed in Module 4 was compound interest. So we have that Mrs. Chioka deposits her life savings of $500 into a savings account that earns 5% interest compounded monthly. So we're going to use the compound interest formula to figure out how much money Mrs. Chioka is going to have in the account after 20 years, and then figure out how long until the account reaches $1,000. So when we're finding how much money she has in the account after 20 years, so we're going to do A equals, and then P stands for our initial amount, so 500, times 1 plus, R is the interest rate as a decimal, so 0.05, over N is the number of times interest is compounded in a year. And in this case, it says monthly, and there are 12 months in a year, so over 12. And then our exponent is N again, so 12 times T, which is the number of years. In your Module 7, Section 4 notes, it does break down what all of these variables represent. And if you're not going to remember, I highly recommend writing it down yourself on this paper so that you have it for the exam. Also, if you're not going to remember the different values of N and what those words mean, I would write that down as well. So like if interest is compounded yearly, then N is 1, semi-annually is 2, quarterly is 4, monthly is 12, daily is 365. Again, that's also in those Section 4 notes. So now that I have the equation, I'm just going to go ahead and plug it into my calculator. Do not do this in steps. I want you to have the most accurate answer as possible, so don't break it down into steps. Type it all at once. We get $1,356.32. It is important here that you remember the units, so the $sign for money, and you only round 2 decimal places because, again, it's money and it only goes 2 decimal places. The second part of the problem says how long until the account reaches $1,000. So now I have a final amount A. So 1,000 equals my initial amount 500 times 1 plus 0.05 over 12. Now this time my exponent is going to be 12t because I don't know the time it's going to take to reach $1,000. That's what I'm solving for. So my first step is going to be to divide by 500. So 1,000 divided by 500 is 2. Next, I'm going to go ahead and figure out what that decimal in my parentheses is. So I'm going to do 1 plus 0.05 all over 12. And I'm going to get 1.0042. And then my exponent is still 12t. This actually isn't a nice decimal. It's actually 1.0041 and then 6 repeating. So if you get a decimal that isn't terminating, which is what this one is, I need at least 3 decimals. So as long as you had at least 1.004, I would accept whatever answer you got as a correct one. Now, it's also important that you also round correctly. So I put 1.0042, even though the initial number after 4 is a 1 in the calculator. That's because after the 1 is a 6, which means the 1 becomes a 2 when I round. And if I were to go 1 decimal further, I wouldn't do 1.00416, I would do 1.00417. But at a minimum, you have to have 1.004. So now I'm going to convert it to logarithmic form. So my base is going to be 1.0042 of 2 equals 12t. Now I'm going to evaluate my logarithm, either using change of base or if your calculator allows you to do different bases, that function. And I get 165.38 equals 12t. Now, depending on how far you went on your decimal, this value might look a little bit different, which is fine. And then we're going to divide both sides by 12. And I get that t equals 13.78 years. Again, depending on how many decimal places you went for the base number for your exponential equation, your final answer might just look a little bit different than mine, but I'm happy to check it to see if it is a correct answer. Important thing to remember, no matter what, when we're solving for t for compound interest, the units for time are always in years. Even if his interest is compounded monthly, time is always in years, and that is an important thing to remember. So last module we covered was module 8, which was statistics and probability. And we talked about mean, median, mode, standard deviation, and correlation coefficient. So the first problem we have is a list of scores for a 10-point assignment. And we want to calculate mean, median, mode, and standard deviation. So in order to calculate mean, we're going to add up all of our numbers and then divide by the total that we have. So that means we're going to do 5 plus 5 plus 10 plus 3 plus 8 plus 9 plus 7 plus 8 plus 7. And we get 62 divided by the total amount of numbers we have, which is 9, which gives us a mean of 6.8 repeating, or 6.89. Next, we're going to calculate median. And in order to calculate median, your numbers have to be in order. So the first thing I'm going to do is write my numbers in order. So 3, 5, 5, 7, 7, 8, 8, 9, 10. Now I can start crossing them off, starting at the ends, and we end up with 7. Now if I'd had either one less number here or one more number. So if I had an even total number of values, I would have been left with two numbers in the middle. And the way I would have found the median is by adding those two numbers together and then dividing by 2. All right, next we have mode, which stands for the most common number. Now there could be no mode if no numbers appear more than once. There could be just one mode, or there could be multiple modes. And in this case, we have multiple modes because the numbers 5, 7, and 8 all appear twice. So all three of them are a mode. Lastly, we have standard deviation, which you can calculate using Desmos. So what you would want to do in Desmos is you would go to functions, which you would have to open the keyboard first. So you have to hit the little keyboard. Then functions, which is on the far right. You would then scroll down to where it says statistics, and then you would want STDEV, which stands for standard deviation. And then you would just type in your values as a list, separating them with commas. It is important that you choose STDEV and not STDEVP because they are different things. And then we would get a standard deviation of 2.20. It's actually 2.2048, but I only require 2 decimal places for standard deviation. Also, when you're entering the values as a list in the Desmos, you don't have to put them in order. You can put them in whatever order they appear in. It will still calculate the standard deviation no matter the order it's in. All right, so last we have a table that shows hours of exercise and weight loss each week. And what we want to do is calculate the correlation coefficient for the data and discuss its strength and direction. So what we want to do is we're going to use Desmos, and we're going to enter our table first. So in the top left corner of Desmos, there's a little plus button, and you'll want to hit it, and then you're going to select table. After you then type in the table, you're going to then go to the next line, and then you're going to type the equation y1 and then the tilde or the squiggle mx1 plus b. And it's going to calculate the line that best fits the data. So the linear equation that best fits the data. It'll give you r squared and r, and then below that it will give you your m and b for slope and y-intercept. So what we want is the correlation coefficient, which is r. So r is going to equal 0.8596. So next, we're going to discuss its strength and direction. So strength means, is this a strong or weak correlation? So the closer you are to +1 or -1, the stronger the relationship. And 0.8596 is pretty close to 1. So it's going to be strong. And then when it comes to direction, we want to know, is this a positive or negative correlation? And if your R value is positive, it's positive. And if it's negative, it's negative. And this is a positive value. Please let me know if there are any other questions you have before the final.